Yeah, today's session, we will discuss about Citrix MCS. So, what is the meaning of MCS? Is Mission Creation Services is one of the provisioning technology with a single instance management. We can create multiple virtual missions. So, we will have one virtual mission, and that's we are going to create into multiple virtual missions, or we can create the catalogs. Okay, so in Zen Desktop also we have previously MCS, but in 7.x, MCS now supporting for multi-session OS and single session OS also. For both, we can support. Okay, so I'll explain how the imaging has been given in Citrix. In the initial Citrix, only previously we have PVS, but in Zen Desktop 5, they have introduced MCS also. Now we have in 7.x, like both PVS and MCS is supported. Citrix PVS and MCS is supported for both single session OS and multi-session OS also. For a single session OS and for multi-session OS also, this is supported. But today we are going to discuss MCS. But which one came before MCS? PVS is there before itself. Later itself, Citrix has given MCS. But today mostly people are using MCS itself compared to PVS. Okay. So then what is the meaning of mission creation services is one of the provisioning technology. Say in order to create thousands of missions, we no need to create manually. Automatically we can provision. Okay. So automatic VM provisioning is going to happen. We will have one master virtual mission, or mostly we'll call that as golden image or golden template. If you prepare this golden image or golden template, automatically missions are getting created through MCS.
Mastering.
Yeah,
Yes, yes,
from that golden template or golden image, the missions are creating. Okay, so then here we are going to use the uh, like a, uh differential disk. What are the disk types also? Mostly storage optimization also is there. Okay, storage optimization also is there, and the image management, all those if any changes need to be performed, will perform the changes even in the uh, will perform those changes in the image itself. If you no need to do 1,000 times those changes. Okay, and we have the snapshot and delta technology. Okay, how it is going to work? Like normally in the VMware View Horizon, it is called as linked clone kind of thing. It's called as a linked clone. So now almost it's also a linked clone kind of technology. How it is going to create also we'll discuss. And thousands of missions also from a single instance we can manage, we can update, we can roll back also if there is any issue comes. And VMware View Horizon mostly supports VMware itself, but Citrix MCS supports multiple hypervisors. That's maybe Citrix hypervisor or Gen server, VMware or Hyper-V, and even cloud also like AWS, Azure, GCP type of. Say it supports hypervisor or multi-cloud also. Okay, so then we have the different type of desktops we have. What are those? We'll discuss. We can create pooled or persistent, non-persistent, dedicated. In pooled also we have pooled random, pooled static. Okay, so then we can manage we have the power management also. Okay, so it's a power management means automatically we can schedule the power depends upon the users or time and idle settings. All these also we can manage automatically. Power management also We no need to power on, power off the missions. MCS itself will manage the power management also. Okay, and most of the administration will do from the Citrix Studio. And as already we discussed, MCS supports like on-premises like we have VMware vCloud or Citrix Cloud or Azure. So with the help of Citrix Cloud also, it's going to be integrated. And if you come to the high line, like what are the steps is, first we need to create a master image. Okay, so master image consists of the operating system, necessary applications, and what are the settings. Say suppose here I'll tell. Say mostly we are taking an hypervisor here. In the hypervisor, we need to create a VM. So we need to create a virtual machine. Once we create a virtual machine, mandatory, we need to install VMware tools, patching, antivirus, all these we need to basic like requirements of our enterprise uh, desktop, all the prerequisites, all the patch levels, virus, all these GAS security patches, all those we need to take care. Then antivirus, all those also we need to take care. So once we done this, like if we want to install any applications also we can install, or even applications also can be delivered through Citrix itself later. Okay, so then once we install all this, like we need to, so maybe applications install after VDA, after these all managed Citrix, so virtual desktop,
Virtual desktop.
yeah, say virtual delivery agent, or previously it's virtual desktop agent. Virtual delivery agent we need to install. If it is a single session OS, install single session OS, or if it is multi-session OS, we can use the multi-session OS. So then need to take the applications also, need to install the applications also. Finally, like we need to take a snapshot. Okay, so better to restart once, then take a snapshot. After that shutdown, okay, say it's not recommended to take the snapshot in the power on state. Okay, shutdown. Okay, before that restart also once, then take the shutdown. Okay, so then here definitely you need to configure your like delivery controllers. So multiple delivery controllers. While installing the VDA, we need to install the delivery controllers, right? Those all we need to configure. Then what is going to happen is it's going to connect to those delivery controllers. And before taking a snapshot, check the event log whether that like VDA has been registered properly with the controller or not. Okay, so configure the firewall settings, all these also. Once we took the snapshot, then from the studio, we are going to create the catalogs. And this time we'll choose the mission creation service catalogs and pooled or pooled random, pooled static, dedicated. So these kind of catalogs we need to choose. Okay, so then like first we need to create a master image, snapshot that master image. Okay, if we don't take the snapshot also, Citrix MCS itself will create a snapshot also, but it's recommended we took the snapshot. Then provisioning the master image and the storage optimization techniques. How what is going to happen in the back end of that provisioning of the VMs we'll discuss. And once we create the catalogs, we need to assign them to the users by entitling user desktops and groups. Then we'll go for update and maintenance. Say whenever we want to do the patching or any new images coming, okay, so only we need to update our golden template. And if that is failures also, we just need to revert back to that. Okay, so like this, how to perform the updates of the mission catalogs, and even in the PBS also will update the PBS VDisk. That is main advantage is simplified management. Mostly, if you have the thousands of desktops also, we are going to maintain one golden template itself. Creation, upgradation, updation, or rollbacks, or single instance management is possible. Single instance management is possible, and like it reduces the storage also. Mostly if you use like a dedicated kind of things, it may use more, but mostly the storage wise also we have a lot of advantages, and fastly deployment, and we have the different flexible options to choose the different type of catalogs to the users. Okay, so as we discussed, we have a lot of advantages. Simplified image management or single image management also, single instance also we can manage. Storage wise also, mostly if say I'll tell one general basic example of the storage wise. Assume I have 80 GB, and if I created into if I created into 100 missions, if I created those into 100 missions, then normally how much I required, maybe around 8 TB is required. But in this MCS, it won't take 100. Okay, at the time of disk we'll discuss, it will reduce lot of size. Okay, so it will reduce lot of size. Okay, it will reduce lot of size. Okay, so what is the main advantage of this is, we no need to have, say suppose if it is 8 TB, okay, we can reduce around 80% of the storage also using a differential disk. Okay, what are those differential disk also we'll discuss. And very fastly, say it takes more time to create thousands of VMs. Okay, but here it's very fastly to provision. And we have a lot of automation also. Okay, so then creation wise, power management wise, updates wise, rollback wise, okay, so we have a lot of automation is there, and it supports all the cloud service providers, multiple hypervisors, hundreds of thousands of missions also we can provision very fastly, and different type of catalogs also there, and any rolling updates or rollbacks, all those also we can do seamlessly, and cost effective also. For the lot of people doesn't have the money for hypervisors to manage, then they can go for the AWS or Azure also. Azure also, like a lot of small and medium enterprises now they're choosing um, Azure also for the Azure DaaS or Azure infrastructure to create. And even if they have Citrix Cloud also, they're integrating the infrastructure from the Azure infrastructure they're going to use. Okay, so that is also one of the good solution, because on premises they no need to maintain very costly hypervisors, those licensing, hardware cost, they're not able to manage that. So that is also one of the solution. But compared to PBS, sometimes performance wise, storage wise, okay, so with the MCS is good, but comparing to PBS, we have this kind of performance bottlenecks, will consume more hypervisor resources, will consume more storage also. Okay, so using MCS. Okay, so a lot of people who prefer to use MCS, PBS. PBS is the best solution for very large scale infrastructure, like where we have more than 2000 desktops or 10,000 desktops like this. Okay, but MCS is the simple solution. That is the reason a lot of companies have been moved from PBS to MCS. Okay, so these all the differences. Compared to PBS we are getting, but the main advantage of the MCS is it's very simple to very easy to set up also. Okay, and for smaller and medium size environments also, this is very easy, but we have more advantages with the PBS. But a lot of people, 80 to 90% of the people already moved from PBS to MCS. But both the techniques have their own advantages and disadvantages. Say small and medium environments, and they want like non-persistent kind of desktops. Then they want to use the cloud or hypervisors. Okay, so then they need to go for MCS. Okay, say here PBS supports physical and hypervisors, whereas the MCS supports virtual, that means hypervisors and cloud itself. But PBS not supporting cloud. Okay, so PBS supports physical servers or hypervisor single instance management is possible, whereas MCS supports virtual hypervisors it supports, and any of the cloud also we can use. Any of the cloud also, so we can use for that. And like say here we have more detailed comparison. MCS creates a full clone or linked clone of the master image and provisions multiple virtual missions from that image. Okay, so when we took a snapshot, again a full clone is getting created for the 100 missions or 1,000 missions also. That full clone is fixed for everyone. On top of that, differential disk, identity disk is getting created. So what are all those we'll discuss. Okay, so then it's going to clone into 100 missions. Okay, the main advantage is very simple compared to PBS, cloud support, integration with the multiple hypervisors, but potential storage bottlenecks and large scale infrastructures, it consume more network storage, it consumes more hypervisor resources also. Whereas PBS is more beneficial in that large scale kind of infrastructures. In the small scale or medium, like maybe we have 2,000 or less than 2,000 kind of desktops, MCS is the best solution. Okay, so then PBS uses the streaming capabilities and is going to like boot from the image using the virtual or physical or virtual kind of desktops. Whereas it uses the streaming over the network, the OS and applications. So whereas large complex infrastructures will use, but main challenge is it's little like a complex kind of thing. But we need to learn both PBS and MCS. Okay, so now here this is going to use a linked clone or maybe disk-based snapshots and cloning those VMs. Deploys linked clones or full clones depends upon the environment. So compared to PBS, storage-wise, hypervisor-wise, more resources have been used by MCS. Whereas PBS is again we need a PBS servers, group of PBS servers that's we need to maintain. That is little challenging kind of thing. Okay, so then here MCS uses disk-based provisioning, whereas PBS uses network-based streaming. Okay, performance-wise, say which one will performance-wise is good is obviously PBS is good, but for 2,000 or 3,000, MCS also manageable. Okay, but PBS required over the network. Lot of OS images are booting. That's the reason we should have very good network compared to MCS. MCS will have storage wise some bottlenecks. PBS have some network wise some bottlenecks on the those two we need to take care. But nowadays that MCS storage, that's not a big issue to the companies. That is the reason they're even for the large scale enterprises like 5,000 or 10,000 desktops also, still they're using MCS. Okay, so MCS has been optimized a lot in the 7.x releases. So what we are discussing is the traditional differences we are discussing, but we have a lot of solutions instead of not going to PBS. MCS itself is supporting all those also. Okay, so then here in this environment, MCS is suitable for the smaller medium enterprises or cloud. Okay, so PBS is large scale environments. Management wise, easiest, the main advantage why the companies are preferring to go for MCS is it's very easy. Again, you don't need to maintain the PBS servers, vdisk update, storage, all that you don't need to manage. Okay, whereas MCS is easy to set up, and even we can create the catalogs, and entitlement also is easy. But as per the technology, we need to understand even the PBS also. We need a deeper understanding of Citrix PBS booting process, vdisk update process, troubleshooting. So that's also the team should have. Okay, that is the reason companies are preferred go for MCS, but in the interviews, they're expecting the candidate should have both MCS and PBS techniques. Storage wise, definitely PBS is the extremely efficient compared to MCS. MCS also uses the linked clone kind of thing, which will reduce the storage, but compared to PBS, not that much efficient. Okay, so then PBS is more storage efficient. Okay, flexibility wise, MCS is more flexible. Different kind of catalogs, all those also we can create. Okay, so PBS is only for the stateless kind of desktops. So which is cheaper? If you have more than 2,000 or 5,000, overall benefit wise, PBS looks cheaper. But if you have less than that, PBS is looks expensive itself. Maintenance, all that initial setup, more manpower required on the PBS side also. Okay, but more return on investment will come with the PBS if you have more number of desktops. Okay, so PBS less cost, but maintenance may be high, more server resources, all those required. PBS required initial investment, but at the maintenance wise, it will reduce less. Okay. So then what are the VMs and the disk? So whenever we create the master image golden template, we took the snapshot, or even we didn't took the snapshot, we creating the catalogs. At the time of catalogs, we need to choose that hypervisor, like in that we need to choose that virtual machine. Then like that virtual machine which we have chosen is our golden template, or that is the master image for us. Okay, so then whenever we create that VMs, a copy of the full clone of the VM is going to be stored. Okay, then if a full snapshot, then a unique identity disk. Say here a full clone, a unique identity disk, and a differential disk. Three types of disk we are going to get. Okay, the first one is the full clone snapshot, that is the read only, and all the say suppose if we have 100 missions in the catalog also, all the 100 missions will use the same snapshot as the OS image. Then we are getting, if you have 100 missions, then 100 identity disk will come, and that consumes 16 MB. Okay, what is the size of one identity disk is 16 MB, and we have a differential disk also. The size of the differential disk is initially it's 0, depends upon the usage. All the user data is going to be stored in that differential disk. So now in this use case, we have a full clone, then we have a unique identity disk, and for each and every mission will have the differential disk. So these all are going to be created. Then only if the time is consumed for the first time, in order to create the full clone or full clone of the snapshot of that virtual machine, then a small automation, a 16 MB of 100 identity disk are going to be created, a zero size differential disk are getting created. That is the reason it won't take more time to create more missions also. Maximum within a 5 to 10 minutes itself, we are going to provision hundreds or thousands of missions. Okay, so then here we have already one VM is there, but additional to this, a snapshot or a full clone read-only disk is going to create. So all the 100 missions also are going to boot from this itself. Then, in order to identify 100 missions, like what is the MAC ID of those and all that identity disk is getting created. Okay, for the 100 missions, 100 identity disk are getting created and the size of that is 16 MB. Okay, how many identity disk we'll have in our environment? How many number of missions we are creating, that many number of identity disks are getting created, and all the delta changes are going to be stored in differential disk. All the delta changes are going to be stored in the differential disk itself. By default, that would be the 0 MB kind of size. But whenever the user started using that, all the data is going to be stored in this differential disk itself. How many differential disk we have is, okay, how many number of missions in our catalog? That many number of differential disks. That means for each mission, one differential disk is getting created. So these all the disks are getting created. So now in this, like the storage is reduced 80% also, because all the 100 missions are going to use the same full clone read-only disk itself. Okay, so additional to that VM, one more full clone kind of disk is getting created. So we will take a full clone also, but what is the main disadvantage of taking the full clone? For every mission, if it is used their own OS image, it's very costly kind of things. Okay, one full clone itself we are going to use. Okay, so then we are going to create what are the type of mission catalogs we have also will discuss. And what is the host connection is? It may be the hypervisor connection, or we can use the cloud also. And host storage, like to the Gen server or VMware ESXi server, will have one data store, like that's maybe SAN or maybe iSCSI kind of simulators we have added. Okay, and shared storage also we can have. Locally also we can have, but that is not at all recommended. Okay, so now here we have one diagram. Yeah, so once we started to create the VMs, okay, so either you can take a manually, we can take a snapshot, or MCS itself will create a snapshot and create a full copy, create a preparation of VM and attach the instruction disk, power on. Okay, so then begin the image provision, the snapshot. Okay, then like which of the missions are getting created, replicate the snapshot. All these are going to like on the hypervisor. These all going to be created. Okay, so create a full copy. Missions are getting created, and each and every mission will get a ID also. Identity disk also is going to store, and each VM will have a full clone identity disk and a differential disk. All the data also user OS data all like in the golden template data is there in the full clone, and on top of that user data also is going to store. Okay, and we are going to use MCS uses hypervisor APIs. Say suppose it's using VMware or it using Hyper-V or Citrix. It uses those hypervisor APIs or SDKs, software development kit, in order to create the missions automatically. Okay, identity disk, each mission unique identity like MAC ID, all those host name, all these details are going to store. Okay, so then the disk is 16 MB, and whenever we have a unique differential disk, okay, all the user data is going to be stored into this. Okay, and that is thin provision, and it depends upon the usage, it's going to increase. And we have some more in the temporary storage, all this. Say now here we have OS disk and identity disk and some of the temporary cache data in order to optimize the OS booting, all this. They're trying to give this cache kind of storage also. And it can be overflow also if it is memory have been exceeded. Says in Citrix MCS that supporting even for Linux also or cloud based also we are supporting. Mostly where desktops are delivered Windows itself, but even it supports Linux kind of desktops also. Okay, so then storage wise, temporary cache, OS optimization, scalability. So these all the main storage wise, which is better. MCS one is the differential and one is uh, identity disk. Okay, hypervisor wise we have more overhead compared to PBS, and while at the time of creation also more overhead. Okay, that is the reason we are going to use the overflow, this kind of temporary cache. So these all the new techniques in order to reduce this kind of overflow and hypervisor resources compared to PBS. Okay, so at the time of new versions, we'll discuss all this. Then we'll discuss what are the port numbers have been used. Okay, mostly already we have 8-year controller communication and controller to hypervisor or host also it's need to communicate, and mostly it uses also for that 80 and 443 itself. Power management, all this also it is going to use. And mission identity service is going to use the port number 8080. Okay, so then the provisioning ports 16,500 to 16,509 depends upon the hypervisor, and 1494 we know, 2598 also ICA port, licensing 7279, and if you are using communication 8443, if you have the certificates, all those, then the main service is okay, it's a mission creation service on your hypervisor. We have the mission creation service. That service is responsible fine. Okay, so mission creation service is responsible for creating and managing virtual desktops. Okay, so then controller also we have studio. On the hypervisors, we have the host service. Citrix host service is responsible to communicate with the hypervisor. MCS service will create all the mission catalogs, all this process, power management, all those. And Citrix host service is responsible to communicate with the hypervisors, and mission identity service, AD identity service, all these also will communicate with the Active Directory also for those missions to store. Okay, and coming to catalog types, so we have persistent, dedicated kind of things or non-persistent. In the non-persistence also we have pooled, either random or we can have the like a pooled static also. Like these VMs are stateless and do not retain any changes after the user log off. Mostly we have task-based workers. Okay, knowledge-based workers. For the task-based workers, better to go for random catalogs. Once the user have been log off, all the user data is going to be lost. Only from the OS image, what is the golden image template we have, from that itself those missions are going to stored. Okay, so then like it's cheaper also. So maybe for the kiosk, call center or lab environments, for this kind of users, better to go for pooled random. Whereas dedicated, like where we can have like the same mission is going to be persistent. The same mission is going to be persistent, and the user will connect to that same desktop itself. And even in the multi-session also, like the same server can be shared by multiple people. We want to reduce the cost. Okay, for all that, we'll go for multiple users also, or we can go for a complete dedicated kind of catalog also we can give for the knowledge base workers. And in the pooled catalog, we have pooled random and static. Okay, so with the pooled random, what is going to happen is there is no guarantee. Again, the user will connect to the same desktop itself. But with the pooled static, what is going to happen is for the first time when the user connected to that virtual machine, a small bonding is going to come between that VM and user. For the second time onwards, when the user connects to the desktop, the same desktop have been assigned to the user. But with the pooled random, there is no guarantee the user will get the same desktop. So with the pooled random, okay, but with the both the use cases, the user data is going to be lost. So that means the differential disk is going to be clean up. Then I have a doubt here. Why we need to go for pooled static? Anyhow, user data is not there, right? Then why we need to go for pooled static?
Uh, let's say we have some help desk guys and they are going to use the same applications every day.
Yeah, applications are in the master image, right?
Mm.
So applications are in the golden template. Those applications, even with the pool random also, if you connect to that another desktop, is going to get that. Then, so why we need to go for pooled static? Okay. So there are some applications. Okay, I'll tell some examples. Those applications are binded to MAC IDs. So that means if I change my MAC ID from another desktop, I may need to log in again, or maybe it need to send an OTP kind of thing, or it need to register again. Okay, so if we have any that kind of application bindings, then better to go for pooled static. Otherwise, otherwise better to use pooled random itself. So in which use case we need to go for static, my applications are binded to MAC IDs or maybe some other bindings are there. Only to that itself it's going to open. Okay. So some restrictions may be there. Say suppose you have a bank manager, that application I'll restrict to only from that bank manager system only I'll open. I don't authenticate from the otherwise. So these kind of use case if you have, then we need to go for pooled static kind of things. Otherwise, we can go for the pooled random itself. But for the task-based workers, the user data is persistent. For that, we need to go for pool, sorry, a dedicated kind of catalogs we can use. Okay.
Yeah, Shika.
And And even we can use the so persistency will be there with dedicated kind of catalogs. So it depends upon that multi-session. We need to choose the persistency. Okay. So maybe for the developers or knowledge-based workers, better to go for the dedicated kind of things. Okay. So these we need one hypervisor. We'll try to set up those by this weekend. We'll try to finish those catalogs, power management, updates, rollbacks, all this. We'll try to finish by this weekend. Okay, I'll share this document also. Go through these documents. MCS versus PVS, MCS differences. Okay, different MCS ports. Okay, so those all just go through. So we'll create the environment for this and we'll create the catalogs. Okay?
Okay.
Yeah, okay.
Yeah.
Uh, eh, for the environment creation, if we
Yeah,
need to do some.
I shared one video, right? In hypervisors. Hyper-V or Citrix Gen server, try to install
Um,
on one VM. Install Gen server. I'll share that video
okay,
again.
okay. Yeah, okay, okay.
Okay, sure.
Shrikant, also one doubt in today's